Second. Okay, everybody. It is workshop 4, and we have the organizers today: Aralim Kamal, Aycan, Hisam Binoa, Fariza Boldekway, and Julduz Yeljanova. So they are going to train us for indoor environmental quality for green building standards, and then we are going to learn the topic. Next time on Thursday, we will have roundtable discussions to develop a methodology for Kazakhstan. Okay, girls, ladies, stage is yours. Please proceed as you like it.
Someone just pointed this line.
I think it is one of you because you only 4 has the rights. What does pointed line? Are you talking about those drawings on the screen?
Yes, yes. Please ignore this small line. Okay.
Why not?
Can we start?
Yes, please. That's what I'm expecting.
Okay. Good afternoon, everyone. Today, me, Aycan, Fariza, and Julduz are going to introduce workshop 4 for the topic indoor environmental quality. The scope of today's presentation will be introduction, 4 certification systems, and conclusion. Let me start with introduction of indoor environment. Why indoor environment is so important and must be included in building assessment criteria. Indoor environment consists of several subcategories: thermal environment, indoor air quality, acoustic environment, and visual environment. The well-designed good indoor environment quality can give occupants the comfortable and healthy place to live and work in, while bad indoor environmental quality can give risks for the human health, such as thermal stress, indoor air pollution, noise exposure, and non-adequate light exposure. These risks can elevate and can be very crucial to the human health. Why? Because it was that about 89% of the time, average human spends indoors, and while elderly people spend 95% of their time indoors. And I think for the Nur Sultan, considering its extreme weather conditions, these numbers could be higher. And the indoor area mostly consisted of home, work, and less for the public areas. And it's really important to make indoor environment high quality for the home and work. Next is short-term health problems connected with the bad environmental qualities. It includes such symptoms as headache, fatigue, poor concentration, and etc. You can see from the screen. And these short-term problems can evolve to the chronic diseases. Next is sick building syndrome. It's mostly for the office building types. The symptoms of the sick building includes the nausea, headache, dizziness, dermatitis, eye, nose, throat, etc. And these symptoms severity is directly related to the time spent inside the building. And these symptoms often disappears as occupants leave the building. So it's clear that the problem is in the building. And why these symptoms appears? They are mostly caused by inadequate ventilation and sometimes some types of decontamination. In order to make indoor environment very high quality, these parameters describing indoor environmental quality should be assessed in the certification systems. Such parameters includes, you can see from the pictures, and we will see if our certification systems discussed today will include these parameters. First, I will start with the Green Globes. Green Globe's certification system was discussed in the previous workshop, but let me remind you, it consists of the maximum 1000 points, and depending on the what point percentage you get, you will get the 4 types of certification level. And next, indoor environment. Green globes consist of 7 categories, and indoor environment is the last of them. It is this in the second place after the energy by the weight system, and the indoor environment consists of 5 subcategories: ventilation, source pollution, indoor pollutants, lighting design and system, thermal comfort, acoustic comfort, and total we have 160 points. Let me start with the first 2. Ventilation system consists of 37 points total, and source control and indoor pollutants consist of 46 points. And in my opinion, these weights are assigned very well. They are the most weighted parameters because as I mentioned before, many of the short-term health problems is caused by the inadequate ventilation and contamination problems. And for the first ventilation system, you can see that it consists of 5 sub-criteria: ventilation air quantity, air exchange, ventilation intake and exhaust, carbon dioxide, monitoring, sensing, and final air handling equipment. In the Green Globe protocol, each of these sub-criteria are discussed in very detail. Next is source control and indoor pollutants. It consists of total 9 subcategories, and also similar to ventilation system. It is discussed very detail in the protocol of the Green Globe. And for the Astana, you can select which one will be applicable, because many of these sub-criteria is designed by meeting the American standards. Next is lighting design and system. It was assigned total 30 points of 2 subcategories. First is daylighting, and the second lighting design. First, daylighting is about the natural light exposure by sun. It includes such parameters as daylight factor, so that human occupants are met the enough adequate level of the sun exposure. However, excess exposure is not good for the human health too, and it also includes parameters as the presence of the shading devices such as curtain or something similar. And the lighting design is mostly about the light obtained from the luminaire, or simply saying from the electricity. And it includes the presence of the minimum lighting level requirements. Next is thermal comfort. It has the least weight value with 18, and it consists of 2 subcategories. First, thermal comfort strategies. It's about the thermal control zones of the different areas of the building. For each type of areas, it is different, and if those comfort zone requirements are met or not. And next is thermal comfort design. It's about the comfort level requirement met with the American standard. And last for the Green Globes is acoustic comfort. It has 29 points total from the 160. It consists of 2 parts. First is acoustic comfort design. It's about the sound isolation of the specific rooms, such as toilet or gym facilities and etc., so that other occupants will not be exposed to the excessive noise. And next is minimum sound transmission class. Also requirements for the door, wall, and the building materials, if it can isolate the sound enough. And Next part of the acoustic comfort is mechanical, plumbing, electrical. It is mostly about if these systems, mechanical system, plumbing system, electrical systems, are met with the minimum sound requirements per each system. Overall, I agree with how Green Globes um, appointed the system within 5 subcategories. I also think that the ventilation and source pollution contamination is the most important ones. However, I don't agree how it is assigned only 16%. I think that indoor environment directly impacts human health and it should be given more. Um, as the previous work in workshop 3, the organizer stated that green globes gives too much for the energy, and I agree with this. And indoor environmental deserves more points. That's my personal opinion. Okay. Next, my colleague will continue with the BREEAM certification.
Thank you very much, Arela. Hello, everyone. My name is Julda Sevdanova, and I'm first year PhD student in electrical engineering. So today I'm gonna talk about BREEAM certificate. So the BREEAM is oldest method for assessment of buildings' environmental performance, and it includes 10 categories. Next. And indoor environmental quality is included in health and well-being category. This category encourages the increased comfort, health, and safety of building occupants. So here we have issues that can enhance the quality of life. They are visual comfort, safe containment in laboratories, thermal comfort, acoustic performance, safety and security, and enduring air quality. Totally, they have 22 points and divided by each subcategory. Next. So the first subcategory is visual comfort. The aim is to increase visual performance by daylighting and artificial lighting. So here we can see that we can put 6 from 22 points. The first subcategory is glare control. Here we use glare control strategy, building form or layout to decrease lighting energy consumption by maximization daylight levels under all conditions, or avoiding undesirable glare in the workplace or other sensitive areas, and inhibit daylight from entering the space under cloudy conditions. The second is daylight, which is 1 or 2 points. Here we have some tables with specific number of credits for different types of buildings. So here we have 5 types of buildings, and you can see that I have attached the link where you can find these tables. So, for example, for education buildings, we have 2 points, and while for retail buildings and multi-residential buildings, you have 1 point. And they have different requirements for daylight and due to the purposes. So the first is view out, 1 or 2 points. View out includes windows and permanent opening. So the windows and opening must be more than 20% of the surrounding wall area. So it's more about the daylight from windows. And the last indicator is internal and external lighting. Here we can put 1 point. Internal lighting is in relevant areas of the buildings is designed to provide luminances level appropriate to the tasks. For example, the luminances of the bedroom will be lower than the luminances of the kitchen, also due to the purposes. And external lighting is designed to provide luminances level to light the roads and outdoor workplaces. The next. The second is air quality, which is very important to encourage a healthy internal environmental environment for installation of appropriate ventilation and equipment. So this issue is split into two parts: the minimizing sources of air pollution and adaptability. The first includes 4 points for every indicator. The previous, the first indicator is minimization indoor air pollution. So we can minimize our pollution by removal of contaminant sources, testing and analysis of our buildings, and then uh, implement the new requirements and maintaining indoor and air quality. The second is ventilation. 1 point, we use ventilation to provide fresh air into the buildings in accordance with the criteria. The first and fourth volatile organic compounds. So we have a table where you can find permitted concentration of volatile organic compounds, which can be in our buildings. So also the adaptability considers potential of natural ventilation, which strategy is to provide adequate cross-flow of air to maintain the required thermal comfort conditions and ventilation. The next, thermal comfort aim is to maintain a thermally comfortable environment through design some thermal modeling. So we use some software to carry out simulation at the detailed design stage to provide full dynamic thermal analysis. So by this analysis, we can, for example, simulate the new building. And for example, summer and winter operative temperatures range in the applied spaces are in accordance with the criteria, and also to limit the risk of overheating or overcooling. The second indicator is adaptability for a project climate change scenario. Here we consider how we can easily adapt building using passive design solutions in order to subsequently meet the requirements under criteria. So here it's more about the adaptation in new changes. So the last is the thermal zoning and controls. This strategy has addressed the following questions, like the zones within the building should be cool or heat, occupancy type, patterns, and room functions. The next. So the next category is acoustic performance, what is very, very important for building occupants, and it ensures the building sound insulation with the appropriate standards. So we have 3 criteria: sound insulation, indoor ambient noise level, and reverberation times. And we have different types of buildings. So these buildings should meet the requirements of this criteria. For example, for education, healthcare, office, and workouts, we can put from 0 to 3 points. For industrial, if in retail and prisons, we can put 2 points if the building meets the acoustic performance standards, and if they meet individual performance requirements for these buildings, we can put 3 points. And the last is multi-residential and other residential institutions buildings. We can put 4 points if they are all meet these requirements. The next. So for this category, we encourage effective measures for safe and secure access to and from the building. So they have 2 indicators. The first is safe access. It's more about to provide dedicated cycle paths, access from and the site entrance and to any cycle storage. So we should also provide the dedicated pedestrian footprints, and they should be signposted. Also the lighting of for access roads, pedestrian roads, and cycle lines. So the second indicator is security of site and buildings. Here we have 3 steps. The first is when suitable qualified security specialist conducts an evidence-based security needs assessment during or prior to concept design. So the next step is they develop a set of requirements, and the third is implementation of these requirements. The next and the last subcategory is safe contaminant in laboratories. They have 2 indicators. The first is laboratory contaminant devices and contaminant areas, and the second is building with contaminant level 2 and 3 laboratory facilities. So for the first, all risk must be considered in the design of laboratory, where contaminant devices such as fume cupboards are specified. The manufacturer and installation should meet best practice safety and performance requirements. So for the second indicator, we can put 1 point. With buildings, we consider second and third level laboratory facilities. Level 2 cover works with agents associated with the human disease. In other words, for example, is infections organisms. For the third level, they work with agents are strictly controlled. For example, yellow fever. So these 2 and 3 level laboratories are very, very dangerous for people. So we need excellent ventilation systems, and we need filters for all areas, and individual fume cupboard. So this is all. We have 22 points in total, and the next my colleague will continue. Thank you very much for your attention.
Thank you, Jules. Now I'm going to talk about the WELL International Building Institute. So the WELL Building Standard is a performance-based measuring, certifying, and monitoring features of the built environment that impact human health and well-being through air, water, nourishment, light, fitness, comfort, mind, and so on. And the WELL is grounded in a body of medical research that explores the connections between the building and the occupants, where we spend the 90% of our time, and the health and wellness. So, for example, in other words, it helps to create a built environment that improves the nutrition, food, fitness, mood, and sleep patterns. The WELL Building Standard is certified by the Green Business Certification Corporation, which administers not only the WELL, but also the LEED certification program and the LEED professional credentialing program. So WELL operates in a points-based system, which 110 points available in each project score care. So all optimization are weighted by varying point values. So the maximum point value of a feature is determined by the sum of its parts. The next slide, please. Yes, WELL project fall into one of 2 main groups determined primarily by ownership type. WELL is owner occupied. The project is mainly occupied by the project owner, which may be different than the building owner. And the second one is WELL core, which the project owner occupies a small portion of the project area and rents most of the spaces to 1 or more tenants. Also, you can see on the screen that WELL certification is awarded at one of 3 levels: silver, gold, and platinum. So certification requires that building meet all the preconditions for all 10 concepts. And building must also undergo on-site air and water testing and other post-occupancy assessment. And reassessment is needed every 3 years in order to maintain the certification. The next slide, please. Now I'm going to talk about the air, light, and thermal comfort and sound, which is related to indoor environmental strategies. And I will talk about the air in detail. So it's the people spend approximately 9% of all the time in enclosed spaces in homes, offices, schools, and so on. And during this time, the inhalation exposure of indoor pollutants can lead to a variety of negative outcomes that can vary in severity. So the most common indoor air contaminants that can be combustion sources such as candles, tobacco products, stoves, fireplaces, the release pollutants such as carbon monoxide, the nitrogen dioxide, and small particles into the air. So, for example, the well provided the enhanced air quality where they encourage and recognize building with enhanced level of indoor air quality that promote the health and well-being of people. So, for example, it means that the meet thresholds for particular matter like PM 2.5 or PM 10 as organic and inorganic gases and so on. The next is, for example, enhanced ventilation design. So it requires implementation of advanced ventilation strategies that can achieve higher air quality levels and thus benefit human health and productivity. One of these ventilation designs is, for example, increase outdoor air supply, which means exceed the outdoor air supply rates described by ASHRAE standards and by percentages. And the other, you can see on the screen, for example, monitoring and awareness that requires the ongoing measurements of contaminant data to educate and empower occupants about their environmental quality. The pollution filtration management that requires project to reduce transmission of air and pollutants from outdoor to indoors through the building envelope and entrance. Also, for example, combustion minimization, it requires to utilize low emission combustion products to or eliminate combustion-based products entirely. The other one is source separation, air filtration, enhanced supply air, microbe and mold control. Next slide. The next strategy is light. And for example, the way buildings are designed has enormous impact on occupants' exposure to daylight. So exposure to daylight has been proven to have a substantial impact on our mood, our circadian health and productivity. So studies have associated lack of exposure to daylight with a disruption in the circadian rhythm of humans and a decrease or in the quality of sleep. So, for example, you can see on the screen the daylight design strategies, for example, which means that its project should be designed spaces to integrate the daylight into indoor environment so that the daylight may be used for visual tasks along with electric lighting. It also provides individuals with a connection to outdoor spaces through windows. So one of the examples is like 70% of all workstations are within 20 feet of transparent envelope glazing, and visible light transmittance is greater than 40%. Also, for example, the circadian lighting design that requires project to provide users with appropriate exposure to light to maintain the circadian health and aligning the circadian rhythm with the day-night cycle. Also, the another things, it's at least it means that 75% of regularly occupied spaces have operable windows that provide access to outdoor air. Another thing, electric light glare control. So it requires to manage the glare by using strategies such as calculation of glare and choosing the appropriate light fixtures of the space. Another thing is daylight simulation, when they requires to conduct daylight simulation calculations to make informed decisions around administration and shading as to provide appropriate daylight exposure for occupants. Also, for example, another example is implementing the ultraviolet air treatment, which means that all central air handling units use ultraviolet lamps to radiate the surface cooling coils. Also, you can see on the screen, for example, the visual balance. The well future requires project to develop and implement strategies to create visually comfortable lighting environment. also electric light quality and equipment lighting. Important thermal comfort. So, for example, the thermal environment substantially impacts building energy footprint, since in many countries heating and cooling is account for approximately half of the building energy consumption. So also the indoor environment is ranked as one of the strongest contributing factors to overall human satisfaction in terms of building environment. So one of these strategies is like verified thermal comfort. So which means the require project to provide high levels of thermal comfort by determining the occupant satisfaction through survey. Also, for example, thermal zoning. The well feature requires project to increase thermal control of the space by allowing control of either conditions of a thermal or movement between thermal zones. Also, for example, one of the another is like individual thermal control it requires to improve the thermal comfort of people in the space through the provision of personal thermal comfort devices and flexible dress code that supports individual thermal preferences. And also, like, for example, providing the thermostat control, which means like temperature sensors are positioned at least 3 feet away from exterior walls, windows, and doors, direct sunlight, air supplies, diffusers, mechanical fans, and other significant sources of heat and or cold. The next is, for example, radiant thermal comfort to independently control ventilation system. Thermal comfort monitoring, which means to monitor thermal comfort parameter using sensors in the building. Humidity control that requires project to maintain optimum relative humidity level that are conducive to human health and well-being. Enhance operable windows that requires windows that should be opened at different elevations to provide desired airflow and different outdoor temperature, and outdoor thermal comfort that to design the outdoor spaces to avoid excessive wind and manage elevated temperatures through shading or other strategies. And next, please. Next is the sound. So, for example, it means that sound, all spaces have some degree of noises from, for example, HVAC equipment, exterior sources, for example, traffic, outdoor equipment, pedestrians, and other building services. So with the sum of these noises, sources exceed comfortable levels, so the space may not function as is intended. So interior noise should be controlled by selecting, for example, HVAC equipment that with a lower sound rating, and by designing the system to reduce sound within ducts. So, for example, we can see here the maximum noise level, which means that it prescribes maximum thresholds for ambient background noise that correspond to optimal levels of interior and exterior noise exposure. Also, for example, sound barriers, which, for example, limit. So the main things of maximum noise level is to limit the background noise level. The sound barriers requires the walls and door meet a minimum degree of acoustical separation to provide adequate sound isolation and improve the speech privacy. The next is reverberation time, to address acoustical comfort by reverberation time based on room functionality. Sound reducing surfaces, for example, using the acoustic material that will absorb sound to support concentration and reduce the reverberation. Minimum background sound, dedicated to artificial sound to uniformly increase speech privacy between occupants. Impact noise management requires a project to manage background noise level by demonstrating compliance with impact noise mitigation techniques. And the last one is enhanced audio devices that requires project to implement organizational policies and provide occupants with devices that support enhanced speech intelligibility and bolster hearing accessibility in spaces intended for telecommunicating, extraction, and public address. So next, Aijan will talk about the LEED credit categories.
Yes, I'm going to tell about the LEED certification. The indoor environmental quality category addresses design categories and environmental factors that directly affect building occupants, such as air quality, lighting, and acoustic design. Next slide, please. Indoor environmental quality in LEED system has 16 points out of 110 points, which is approximately 15% of total. Next slide, please. It consists of 2 prerequisites and 9 credits. Once the requirements for prerequisites are satisfied, the points for the credits can be earned. These categories include requirements for air quality, lighting quality, acoustic design, ventilation, as well as for the daylight, thermal comfort, low emitting materials, and quality views. Here you can see that the most of the points are rewarded for the air quality. Next slide, please. This table demonstrates the intents of the all prerequisites and credits. The main aim of these categories is intended to promote occupants' productivity, comfort, well-being by improving indoor air, by introducing daylight into the space, providing a quality thermal comfort. It considers also quality views and interior lighting. The LEED certification has only very detailed and specific requirements, and there are many of them, so I'm not going into details for each one, but I would like to present 2 prerequisites and one of the credits just to show the example of the requirements. Next slide, please. The first prerequisite is minimum indoor air quality performance. There are 2 cases for mechanically ventilated spaces and naturally ventilated spaces. They both should follow the requirements described in the ASHRAE 62.1. It is American Society of Heating, Refrigerator, and Air Conditioning Engineers. And in the standard for ventilation system and design, detailed design procedure is provided. Therefore, in order to satisfy these requirements, all procedures should be implemented in the design. Next. The next prerequisite is environmental tobacco control. So it is intended to prevent or minimize exposure of building occupants to tobacco smoke. The first option is to eliminate smoking in the area at all and inside of the building. But however, sometimes it cannot be implemented. Therefore, they suggest the second option. It is to prohibit smoking inside the building or to separate the smoking areas and locate them at least 25 feet from the all entries. If this requirement cannot be implemented, they should provide the documentation and verify that they cannot implement this requirement and to use signage that postpones the smoking in the area of 10 feet. Next slide, please. The next credit, for the next credit, you can obtain 2 points. 1 point will be rewarded for the conduction of flash out Flush out is a process where outdoor air is forced through the building before the occupancy. And the next option is to conduct indoor air quality testing according to ASTM or EPA standards, and to demonstrate that contaminants in the air do not exceed the levels which were detailedly specified in the lead requirement. That's it. Next slide. Here you can see the summary of the all certifications. We can see that WELL certification has the highest percent weight for the indoor environmental quality. So, however, some of the indicators are not included in all certifications. However, you can use any indicators you would like, which will be applicable for the project in the Kazakhstan. Thank you for attention. Now we would like to conduct the Kahoot game to check.
Yes.
Farida.
Okay, thank you very much. It was a nice presentation. So you are going to make a Kahoot game now?
Yes.
Yeah.
Yes.
Okay, so we have time. Yes, it is good. Okay, please proceed. Everybody wake up if you are sleeping, but I think it was not a kind of presentation you let you sleep. It was interesting though.
So you can see the pin and can join, and we'll start the game.
Okay, guys, please join the
So
waiting for you. Girls, warm people. You are the organizers. You have to attract people. Okay, some people are maybe sleepy or just away from the keyboard. But I see only 1, 2, 3, 4, 5, 6 people. It makes 6, 10, 11. Still 8 people are waiting. We are waiting for 8 people.
I think people, the number of people decreased instead of increasing.
Yeah, it is. Someone has left. We have only 5 people.
So we can start with 6 people, for example. I think it's the number.
Anyway, go on.
Okay, then. I will start
Please.
our quiz, which is about indoor environmental control quality. Okay. Next question.
Oh, it's a mistake.
Mistake.
Professor, are you playing with us or not?
I am following, not playing.
You should try to play with us.
Okay, next time I will do it. But if I play, you have no chance.
I'm here. I'm always on the first place.
Yeah.
You
No,
never know.
you cannot beat me. Okay, you will see next time. Now I am checking myself that I am giving almost correct answers for everything. Next time, Alex, I am there. I dare you.
Waiting for you, Professor. Waiting.
Okay.
The last question, guys.
Congratulations, Dr. Douglas.
Good job, guys.
Thank you very much.
Thank you for participation.
The second
Yes.
slide is drawn. So that's it for the quiz. And if you have any questions for today's workshop, or opinions, you are free to add. You can share the PPT again if you need.
Yes, thank you, Aralim. It is a good presentation, and now this is a question and answer session. Anybody has any question or request? Okay, guys, for the roundtable discussion, if you need any extra material like a kind of Excel sheet or something, just you can request it now from the organizers. Anybody has any idea? Any question? Please go on.
Could you prepare Excel file, girls?
Yes, we will prepare it.
Supporting material, yes, we'll prepare.
Thank you.
Okay, such a file is quite useful. People are just referring them and comparing the materials, what they have, then they are selecting the most proper ones for. Anyway, while I am listening, you guys, girls, sorry, there was no man, so let's say girls. I just realized that some of the building certification methods are quite designed for not home environment, not residential environment. It is designed for buildings. I mean, commercial buildings. This is what I do understand, especially BREEAM. I mean, BREEAM specific design for commercial buildings, because some of the criteria are not very. For example, there was one interesting criteria. It was saying that the windows, for example, how if they are allowing people to open it and make ventilation. So in household environment, all the buildings are just open and close type of building windows. So this is my understanding that the indoor air quality assessment might be different for place to place, building to building. Okay, if you are focusing on hospitals, it is different. If you are focusing on residential buildings, so our target for the next time is a kind of building assessment. I don't know. Did I tell you that we are making a kind of roundtable discussions for residential buildings only?
Yes, you mentioned it before.
I mean, because if you remember that, especially for PhD students, they are supposed to make a kind of assessment for commercial and residential buildings. Okay, it is their. I mean, for master students, you are going to make only one assessment for residential buildings at the end, but PhD students are going to do two assessments. So we may also consider that if the assessment is valid for residential buildings or commercial buildings, let's think about it. But you can still consider that the roundtable discussions are mostly for residential buildings, okay? So
Okay.
and that some indicators might not be good to put in, especially for indoor air quality. Okay, so these are my concluding remarks, and I don't have any questions. If the others are not too, we can end now. Let's wait and ask again if you have any questions, guys. No? Okay, dear organizers, do you have anything to add?
It was good to present today. Thank you for your attention. Okay.
Okay, thank you. And it is end now.
Thank you very
Ending.
much.
Okay, it is ending now, and see you on Thursday. Just be ready for the next stage of roundtable discussions. It's going to be before. I mean, when it is the break? Break is not next week, right? The following week.
After the next week.
After that week.
Okay, so we don't have a break on
Next week.
Okay, okay. See you guys on Thursday.
Yes.
Okay,
Thank you.
goodbye.
Goodbye.
Bye.
Goodbye, Professor.
Goodbye.